Hey guys, welcome to Binary Bag. This is Teja. From today, we are going to provide you the machine learning series. Today is the first series, Introduction to Machine Learning and Data Preprocessing. In this series, you can learn machine learning from scratch. The only prerequisite is Python programming. You want to have a basic knowledge about Python programming. And then we will start our first module. Today we are going to learn about introduction to machine learning and data preprocessing. What is machine learning? Machine learning is a process to train a module, to train a system based on their past experiences. Based on the past experiences, it can automatically train the system. They can rectify the problems based on the experiences. Next, why is machine learning important? Now, many industries are developing more robust models capable of analyzing bigger and more complex data. Nowadays, data has become more wider. In previous days, we can see the decade ago, we can see very less data. Like that's why the machine learning is not that much famous. In nowadays, machine learning is famous because of the big data and the robust data in the industry and more accurate results on the vast scales. ML tools enable organizations to more quickly identify profitable opportunities and potential risks. ML is now everywhere in the every industry, giving very profits to the industry and a very uh, clean behavior based on the experiences. Then, what is data pre-processing, and what are the steps in the data pre-processing? In the data pre-processing, we have to follow several steps. For step one, we have to import the required libraries. Step two, we have to import the dataset. Uh, in machine learning, the very important part is dataset. If you go to your friend, he said, I am doing a machine learning problem. He said, you can ask them, what is the dataset? If he said no, I am not using any data set, then he is not doing a machine learning problem. The very important thing in the machine learning is data set, because machine learning is based on the past experiences. That's why we need a data set in our machine learning problems. And step three, the handling the missing data. If we do not replace the missing data with some other values, then we will get very low values or less accuracy, or something we do not get accurate values. And second and fourth step is encoding a categorical data. In machine learning, the data will be in the form of vectors or numbers, binary form. Strings cannot be executed much faster in the machine learning, in our Python also. And step five, we have to split the data set into test set and training set. We will see this in action. Now, here you can see that we are importing the libraries. The basic libraries are NumPy and Panda. See, step one, importing the required libraries. In every language, there are certain libraries to import where you can meet the maximum requirements in that. In machine learning, there are lots of libraries. The basic two libraries are Pandas and NumPy. Pandas is everywhere we can use that in the machine learning. Basically, at start we use Pandas to extract to read our dataset, and NumPy is to uh, make our dataset into the certain arrays. See, we can see in action. See here we are importing NumPy as NP. As NP means we do not call always NumPy in different sections, different blocks. That's why we have simplified it to the MP. And as pandas also, import pandas as PD. We have simplified into PD. See, if we run, it does not show any error because the steps are very clear. Let's wait some time to run it. I think it's taking a lot of time. Yes, see, it does not show any error because this means the libraries are successfully imported. And our second step is importing the dataset. Why why dataset is more important? You have learned before, because in every machine learning problem, the dataset is important. A dataset generally available in .csv form. .csv means comma separated values. In comma separated values, each of the files will be differentiated with the comma. A CSV file stores tabular data in plain text. You can see that the plain text will be stored in a comma format. Each line of the file is a data record. We use the read underscore CSV method of pandas library to read a local CSV file. We can see in the runtime. Then we make separate matrix and vector of the independent and dependent variables from the data frame. Let's explore this. We can see that the dataset is dataset. I'm calling that reading the dataset as dataset variable. We can see that we are calling the pandas as pd dot read underscore csv file. In that read underscore csv file, using that read underscore csv file, we are calling the dataset. In our case, the dataset is cars.csv, and the delimiter is this one. Means we are using that. Let's explore. Let's see the dataset once. See here, cars.csv. This is the dataset. In the here you can see that every attribute has been differentiated with semicolon. We can this is the format of data CSV format. This is the data set we are using now. You can see that cars.csv. This is that file. We are importing the file. Let's see. It does not show any error. That means it is successfully imported to dataset variable. And then we are we have to see what are the variables or attributes in the dataset. Let's see, we are calling using we are making another variable df dataset.head. Head means top items. We are calling top 10 variables, like a df is equals to dataset.head. We are calling the df variable. Let's see. You can see that car, mpg, cylinders, displacement. You can see here car, mpg, cylinders, displacement. We are importing the first 10 values of the data set. And the third step is handling the missing data. The missing data, we have to handle every missing data. It is very important to handle the missing data, because sometimes you can get very less accuracy, or sometimes you will go to error also using the NaN values. The data we get is rarely humongous, homogeneous. Homogeneous means in the same values, like it does not get any null values or missing values. But sometimes the value is missing due to sensors or noise in the noise in the capturing the values, due to various reasons, and need to be handled so sure that it does not reduce the performance of our machine learning model. We can replace the missing data by different methods. We can replace it by different methods. Let's explore the different methods. here we are here you can see that nan value. Nan means it's a missing value. You can see that nan. And first, here we are. You can know that the basic from the Python, -1 means last cell. We are deleting the means we are cutting off the last cell because we don't want not that accurate in the predictions, just in the training set. You can run it. If you can see that our last cell has been eliminated, you can see 120 12.0 70 12.0 70 us. It has been eliminated from we have to by we have to handle the missing values. We have to import simple imputer. The simple imputer function is in the sklearn.impute library. We are calling that from sklearn.impute, importing simple imputer function. We are making the variable as s underscore imputer. We are calling the simple imputer function. We are giving the missing, we are analyzing the missing values is equals to np.nan. In the place of np.nan, you can see that nan values in the place of np.nan, we are using the strategy called mean strategy. Mean means averaging all the values and taking all the values and make the average. We can put the average values in there. We can use different types of strategies also, like median, and we are giving verbose as 0, like in the some axis verbose we're running. It takes some time due to the import. You have to import the library. Yes, it has been imported. And in the next slide, we can in the next cell we can see that we are calling s underscore imputer to store the these imputer values. From this is a basic Python. You can understand this. We are taking from the first cell to the last cell, dropping out the last cell. This is the simple Python code where we can calling from the s underscore imputer variable. We can call that df variable. You can see that there are no missing values. The nan values are replaced by the mean values. This is the one type of method. And another, the simple method is we are taking another data set of Boston housing. We are importing the pandas as PD, pandas library, and reading the Boston housing data set. And we can search for any duplicate values in the data set. Sometimes it may be, it's very rare to see the duplicate values, but we have to check if there are any duplicate values. We can run the cell. You can see false means there are no duplicate values. You can set that, but by using some function, it's 0 because why it's showing 0 means there are no duplicate values. That's why it's showing 0. By we in the previous missing value slide, you can see that we are using the strategy mean. Here we are using the same strategy mean, but in a different manner. Directly we are calling df dot mean. You can see that for every attribute we can get the mean value. You can see here I'm having ls stat value, some values as nan. Here we are getting the mean values by using the in the inbuilt df fill na variable. We are calling the fill na. We are replacing that na variables with df dot mean. You can see that we are replacing the mean values in the na values. You can see we are calling the df set data set. Here we are getting that ls stat value as, here you can see the mean value of ls stat is 12.71543. In the 501 slide it's nan, and the fourth one it's nan. You can see that 501 12.715432 and fourth 12.715. The mean values has been replaced with the nan values. It is the second step, third step. And the fourth step is encoding the categorical data. Like categorical data means sometimes you can get the data as yes, no, and sometimes like summer, winter, rainy. We can give every variable for every summer, winter. For summer we will give 0, or winter we will give 1, rain we will give 2, because by assigning the values it is uh, our process or runtime will be very fast. That's why we are using the encoding the categorical values. Let's see what there. Categorical data are variables that contain labels, values rather than numerical values. The number of possible values is often limited to a fixed set. We need to encode variables to numbers. To achieve this, we import label encoder class from sklearn.preprocessing library. We have to import uh, from sklearn, we have to import sklearn.preprocessing. This is a standard library in the Python. We can see in the runtime. You can see encoding. Uh, you can see that we are importing the basic libraries as numpy, pandas, and in this case, we are uh, we are making our own data set because of to show the categorical values. Here you can see sunny, overcast, rainy. These are the categorical values like hot, mild, cold. We will give one number to each of the variable. Like hot, we will give hot to 1, like no to 1, and my and different like this. We can run this. This is our data set. Here we are importing the pre-processing from sklearn. From sklearn we are importing the pre-processing. We are calling that pre-processing dot label encoder because we have to encode one label to one attribute. That's why we are calling and calling this variable. We are storing in the le variable, and we can see that we are encoding the weather as weather underscore encoded le. We have stored the pre-processing dot label encoded in le dot fit underscore transform. We are calling the transform function to encode the weather. You can see we are encoding the weather. We can see the print the weather encoded values. You can see it has assigned sunny for 2 and overcast for 0 and rainy for 1. It has encoded the different values for uh, different functions, and we can see temp and play also. We are visualizing this. See, visualizing the temp and play same. In the temp it has assigned 1 to the hot and mild to 2 and cool to 0. As in play also no to 0 and s to 1. And next it's very important to make it in the tuple. In the tuple form it is very easy to compute the algorithm to compute it. We are using the list function to encode the weather values and temperature values to making it to make it into the zip. We are making it in the tuple. You can see the tuple has been formed. And the next step is splitting the data set into test and training set. Because we are having a large data, we have to first train the data. You are and test our data also. We have to test the accuracy of our data. In that first, we have to give some amount of data in the test and some amount of data into training. Basically, we have trained the large data and test on the small data. And based on your preferences, you can give training data as 70 or 80. If your data is large, you can give 80 also. Sometimes it's preferable to use 70/30 and 80/20. By For this, we have to import train underscore test underscore split module in the sklearn library. We can see that from sklearn dot cross validation import test underscore train underscore split. It is the basic library to call the training and test set. This you can see in the later lessons. We are splitting our module. We are splitting our data into train and test of the x values and train and test of the y values. Y is the we have to predict the values, and x is the given values. Like we are ha we are having the values, and we have to predict the y values in the future based on the experiences. That's why we are giving the y values here and the x values here. We are calling them train test split. We will call the x value where we can give, we can assign in the above. Here I have not assigned, that's why I have taken this something like wine dot data or wine and random state, something like anything you can give. It will give the data set to randomize all the values, because you do not get you do not get always the same training set and the same testing set. These are the basic steps you have to follow. Uh, you have to follow the pre-process the data. It can be useful in every machine learning algorithms, like in classification algorithms and regression. Basically, in the machine learning, we are having three categories like supervised learning, unsupervised learning, and reinforcement learning. In supervised learning, we use the used of the using the labels, we can predict the data. In unsupervised learning, we do not give any labels. Uh, that the system will automatically make it the same variables into the clusters. In the reinforcement learning, and the third one is reinforcement learning. In the reinforcement learning, we train the system, the robot or the system. Like if you get true, I will give the some plus points, and if you done wrong, we will give the penalty. In by that case, we are using the reinforcement learning. You can get all these all, all these work on my GitHub link. GitHub, you can check my GitHub in the description. You can get the PPT also in the description. Today we are closing this. Uh, from tomorrow we are starting with simple linear regression. Stay tuned.